Ed Schouten, who could not be with us in person. He's going to give us a rundown of the next version of RE API, or his proposal for the next version of RE API, if I'm not mistaken. So take it away, Ed.
What's the backstory of this talk? Over the last year or so, we've seen in the remote API working group that people keep on dropping by. They come up with these awesome proposals of how to make the protocol even better than what it is right now. But the end result is always the same, namely, yeah, we'll fix it in REv3. But the problem is that like we didn't actually have like a clear timeline or even like an acceptance on whether there was going to be an REv3, right? So it always felt a bit like a way of just saying like, yeah, we're not going to do it, right? So we had this discussion a couple of months ago about what to do with all these proposals, and the consensus among the working group was, you know, if we're going to do an REv3, it should better be worth it, right? We shouldn't just be calling like REv3 to add this tiny feature to the protocol simply because we're too lazy to sort of shoehorn it in some other way, right? It should, you know, if we're going to do REv3, we should like break the world, but like break it for the better, right? To actually add meaningful improvements to the protocol of like, you know, that meaningfully affect how people use the protocol in a practical setting. So with that in mind, I started writing a document, which I'll sort of share on screen because it is my slides. And we'll sort of run through it, and I'm sort of going to explain what the motivation was for me, including those things in there. So share my screen now. Here we go. Oh, now I've already spoiled it. So as you can see, this is just a public document in Google Drive. I've sent out a link to it on the mailing list. What was it? Sometime last month. And you know, I intentionally added like a lot of offers to it, and your name could also be here, right? So if you also see the shortcomings of the existing protocol and want to sort of improve it, please let me know. This is like multiplayer notepad, right? We should like try to put as many things in here, right? And the focus of this document is not to sort of already start describing how we want to do things, but just discuss it from a high level. So I'll sort of briefly run through for each of these, right? So this is an interesting one, generalizing execution. What I've noticed is that also like from my personal experience, but also what I've seen at certain conferences is that there's a desire to make use of remote execution to do hardware testing as well, right? Really tempting because you don't want people to have all this embedded hardware just lying on their desk. You just want to put it in the lab somewhere, and people from behind their laptop can just call Bazel or whatever tool they want to run these hardware tests. The remote execution protocol isn't really built for that, because if you sort of take a look at the protocols it is right now, every action has a command, and a command is basically just standardizing what a Unix process is, right? It has command line arguments, it has environment variables, and lists of paths to capture. But when you're doing this sort of embedded hardware testing, it's not how hardware works, right? For hardware, you need a base image that needs to be flashed, maybe some like NVRAM options, or it could be like anything. So what you see, what most people do is that they then just make, say, a Python test or something like that, which runs on a computer that's hooked up to the embedded hardware, right? So you take some kind of small computer, it could be a Raspberry Pi, it could be a Mac Mini, whatever, you just hook it up to the embedded hardware, have a simple Python test that actually launches the test. But that also has its fair share of downsides, because it means that, first of all, or like most importantly, you don't even know whether the hardware is being left in a decent state, right? So especially if you sort of have a single, the worst example would be if you had, say, a Raspberry Pi that's hooked up to multiple devices that you want to run tests on, right? So it's a Raspberry Pi hooked up to like 4 different revisions or of a board, or it could even be the same board multiple times. You might want to schedule multiple tests in parallel on them, but then everybody needs to be really careful with Python launcher tool to sort of not mess with each other's boards, right? So all of that is really hairy, and I think a future version of the remote execution protocol to really focus on, like, could we generalize what an action is, right? Changing from just like a Unix command to something that's more flexible. So that's why I put that thing in here. Somewhat relatedly to that, where I think the remote execution protocol isn't really good is in like the area of output streams. There's support for standard out and standard air. But if you're, first of all, dealing with hardware tests, you have to deal with serial ports, etc. Even if you're just running tests in certain operating systems on a Linux box, you might want to capture stuff that's in the D message. On macOS, you want to capture the OS log calls that are being made by the process, etc. And I think the remote execution protocol would also improve significantly if we sort of spend some time and actually tidy it up, right? And still standard out and standard error there as some kind of like predefined output streams, but make it so that any kind of worker could also have alternative streams, right? So like another thing that at least for like the use cases that I've experienced setting up Buildbarn is there's currently sort of what's really good about remote execution protocols that it's already pretty good at sort of guaranteeing integrity of data, right? 99.9% of all the data is already stored in the cache. So, you hardly see any data corruption in there, and that's all great. But what we're sort of missing is sort of more like two things: either like be able to sort of verify action cache results, sort of end to end. Is an action result that I'm downloading actually built by a worker that belonged to this cluster, right? That's completely absent right now. And relatedly, there's also no support for actually sort of encrypting results. So if you have an environment where, say, you've got a single storage pool that multiple projects can all be using, right? But it's just that certain projects they just tend to have different workers, right? Then there's absolutely no way where information can be hidden like between the sort of those multiple tenants that are sort of building those projects and using those multiple workers. That's a bit messy, and especially for sort of larger organizations, it's not really desirable that each project sort of spins up its own cluster or has its own storage pool, or the maintenance for that is all like sort of non-trivial. It would be nice if there were better facilities for actually sort of saying like, hey, let's just offer storage as a service. Let's offer scheduling as a service, right? But that people can just bring their own workers and have sort of this end-to-end guarantee that nobody's able to look at the actual sort of input files and output files, and at the same time also guarantee that like what you just got back from the schedule also sort of was actually generated by a worker. So yeah, leveraging crypto. Related to the area of storage, like encrypting storage, is also like the lack of sort of references between objects. Right now, what you see in sort of the remote execution protocols that the cache is just a flat namespace, right? There's no difference between a file and a directory object. So you could even just upload have an action that has a directory as an input file, right? And that is causing quite some grief here and there, right? It makes it pretty hard to, for example, build like sort of a universal tool that's capable of sort of archiving build results, right? It really needs to be sort of aware of what the remote execution protocol looks like. And also, it means the protocol isn't really extensible. Say you take the existing directory message, but you sort of add another type of file to it, right? Or you extend the existing file. So for example, here in this document, I'm talking about resource forks, right? A file doesn't just have a payload, it also has sort of this alternative data stream of like, an icon or internationalized names or that kind of stuff. There's no way you can easily add that to the existing message without actually sort of breaking existing servers that assume that there's no additional references in there. I've got 13 more minutes. Okay. Then I'll make sure to sort of proceed. Yeah, thanks. So that's really problematic, and I think that could be solved by actually making it so that cache objects are actually like have native references to them, right? And sort of also like once we have support for decent references between files, one of the things we could also do is add support for eliminating large CAS objects. Right now, a 10 gigabyte file is stored as a single CAS object that's also 10 gigabytes in size. And this makes them annoying to transfer, right? If a transfer goes wrong halfway, you need to resume that, and resuming also has its fair share of issues, at least in RFV2. And it would be nice if we could just simply say, no large objects ever exist. The largest object you have is, say, 60 megabytes. And if it's larger than that, needs to be cut up, right? And having native references in the CAS is sort of a, I'm not saying a prerequisite for it, but it would make this a lot easier. And also, when it comes to like storing directory hierarchies in RFV2, what's a bit odd is that the way directories are encoded for like input routes is different from how directories are encoded for when they're outputs of a certain action. And that means that if you want to take an output of an action, like a large directory that was being generated, and you want to pass it on as an input to another action, you can't sort of do that directly. You first need to download the tree object back from your cluster, unpack it locally, and then upload it again in this sort of decomposed form. And that's fairly problematic because that on its own is already pretty bad. But you see that sort of that as a result of that tools like Bazel have a hard time keeping an output directory opaque. There's quite a lot of pieces of code in Bazel where they sort of iterate over an output directory, go over all the files. Even when placing an output directory in input route again, it's basically regenerating all of the directory objects again, even though they could have been like extracted from the tree object. So memory usage of Bazel tends to be sort of proportional to the number of files that are in a directory, as opposed to just treating it as an opaque thing. It's like O1 memory, O1 time. Yeah. This is something that I also like to hear a lot more about, how other distributed build systems, like other implementations other than Buildbarn, sort of see this. But what I've noticed is that, like, the standard only talks about this content addressable storage in this action cache, but in practice you need a lot more data stores to sort of make it all work fine. So, for example, in the case of Buildbarn, we have a dedicated data store that keeps track of timing information for each action. So where we store, like, this action takes a minute on a 1-core system, but we know that it only takes 10 seconds on an 8-core system, right? And that data is used to make smarter scheduling decisions in the future, right? And the same with file system access patterns. For each action, we store a Bloom filter of which files and disks are being accessed. And those are all sort of key value stores. So it's not just 2 key value stores, the CAS and AC. It's basically 5 of them, just to sort of make all of the features in the cluster work. And for Buildbarn, we're constantly coming up with like these custom protocols and custom protobuf messages, all that kind of stuff. But it would be nice if the action cache on its own, or could be generalized into sort of a generic key value store for all this auxiliary data. So still making it so that almost everything is stored in the CAS, but that there's sort of a helper data store alongside where we like build clusters could put all this custom data in that doesn't fit this CAS kind of model, right? And then there's also like some sort of minor improvements, cleanups we could make to the protocol. One of them is that if you take a look at the existing protocol, we decide to make use of some of the protocols that were part of like the well-known Protos API, the Google APIs repository, such as the bytestream protocol, the long-running protocol. And I think the intentions there were good. Like, that way we get sort of reusability. We can make use of existing tooling in that area, but the tooling is simply not there. So I think it would make a lot of sense to simply sort of abandon these protocols and make it so that RFV3 is sort of a completely sort of separate protocol that isn't tied to bytestream or long running, and define everything sort of in a native way, the way we want it, right? Then here, last but not least, I think that there's also going to be a talk about this later today, action graphs. I don't want to like spoil too much on it, but the idea is roughly that instead of scheduling a single action, you can sort of specify a small graph of sort of smaller pieces of work that all need to be executed as a single unit. If we're going to overhaul the protocol, then in my opinion, that should just be a native part of it. There's no need to sort of have that as like a separate helper protocol. It could just be like nicely fit in there. Below, I sort of have like even more things like a scratchpad area, and this is also like, you know, even if you're not sort of willing to sort of write long pages of text and add them to this document, you know, please leave notes behind here, because this is like really valuable input for me to sort of see how people in the community think about like the existing protocol. Also leave comments behind if you think I'm wrong in certain areas, right? This document doesn't need to reflect my opinion, but it needs to like reflect the opinion of the people actually using Bazel, who are part of the working group and want to make the protocol better. So this is sort of like everything I want to say at this point. Let's leave a couple of minutes open for questions, if any.
Any questions? Also, if there's any questions on the meet itself, you can unmute yourself and ask, or write on the chat. There's not all. George?
Yeah, sure. I'll ask. What can we do for next steps for this? Because, you know, you and I and maybe a couple of other people within the RE API meeting agree that it's a good opportunity to actually clean up some of the stuff that we wanted to clean up and do things in a way where we're able to fix problems that we couldn't otherwise, and that we have the opportunity to like just push in better designs or clear indications of where we expect to be using things. What should we do next after we've agreed on some major subjects here? This doc is great, and we need to be looking at it a little bit more and trying to flesh out some of the ideas. But, you know, do we need a theme? Do we need to pick some hard end date that says we start pushing things out at this time, or do we need more buy-in from the rest of the community / enterprise offerings?
Yeah. So I think like the first and foremost thing we should do is, and this was also when we proposed writing this document, was the existing of this document doesn't mean that we're already committing to making an REV3, right? The question we had as a working group back in September, August, when was it, was, should we even be doing an REV3, right? And that's the first thing we need to answer. And like, we should just first try to get an answer to that, right? So first of all, the working group should now sort of agree on like that these things are actually worth sort of breaking the protocol for, right? Or like moving on from REV2. But at the same time, we also need to sort of go past the maintainers of existing build clusters or build clients and ask them, is this something that they'd actually do? Is this sort of worth enough spending additional effort for, right? Because if we're going to make an awesome REV3 and it's never going to be used, right? Because everybody's still in REV2 and like doesn't want to commit to sort of moving on, then we've also failed as a working group, right? That's that's for sure. And,
Yeah.
and I think after sort of all of that is answered, I think only then it would make sense to sort of actually go deep on the details and, you know, for each of those points in there in the document, each of those chapters, you know, try to sort of tackle them separately, have separate discussions on them. Like, you know, how do we want to make it that the cast gets decomposed into smaller objects, right? And I think once we start doing that, then like REV3 will automatically start to sort of get a shape, right? That's we just collaborate on a .proto and sort of see where it goes. That's my thinking.
Yeah.
What do you think? Right.
What I think is, I think we need to, like, you bring up the good point of the conversation is still happening as to whether or not we need a V3.
Yeah.
And we need to like figure out whether or not that's that's a lone man's opinion. We won't say his name, or if we really do need to reconsider the fact that making a new protocol will get adoption from no one and accomplish no new goals associated with what we're doing. Or maybe we can wedge everything into V2. But I think we've come up with enough cases that we can't wedge into V2. The question for now is whether or not that justifies a V3 existence and whether or not that quells the critics.
What can we not wedge into V2?
What can we not wedge into V2? We can't drop the byte stream protocol into V2.
Okay, but why is the byte stream protocol a problem?
Why is it a problem?
Well, so
Doc.
yeah. So we can talk about the byte stream protocol specifically, but one thing I think is something that can absolutely not easily be put into REV2 is crypto, right? That's already fairly hard.
Well,
mainly for the reason that sorry.
You got it the wrong way. You're saying you want to put in crypto, but you're not saying what problem you want to.
Oh, well, that's something I've already explained, right? And I can sort of rehash it. So
yes,
it is fairly common for larger organizations to have stronger requirements on traceability, like did an action result that I just downloaded not just get written into the action cache by some random person, but it had actually come from a worker that did the build, right? So that's a lack of signing. And then also encryption of the cache contents, where you have multiple teams working on individual projects. They do want to sort of use the same infrastructure, but it's not acceptable for them to sort of have all the objects stored in the cache in unencrypted form, because the people working on a build cluster might not be disclosed in those kinds of projects, right?
Again, I think you're not putting the problems first, but you're sort of putting the solution first. So let's say I have a large organization, I have multiple teams. Why isn't multi-tenancy enough for these teams? Why would they accept cryptography over physical separation of the storage systems? It seems like the physical separation would be much more secure compared to like just cryptographic separation.
Well, yeah, exactly. But in the document, that's also explained in detail. For example, it is also fairly common for people or for large organizations to have caching infrastructure for their builds available, right? And when you start to get on-premise caching in this specific case, when you start to sort of set up these on-premise caching machines, right, you would also need to use the same kind of separation over there, right? Because otherwise, people on project A could simply download the data corresponding to project B through that office cache or from that office cache. And it also means that the people maintaining the fleet of office caches are essentially disclosed to all the projects within the organization. It's not necessarily the case that that's acceptable. Yeah.
You're claiming that cryptography solves this problem, but it doesn't. Namespacing and multi-tenancy solves this problem. And then cryptography is just sort of a layer on top of that to encrypt the files.
Yeah, exactly. But the problem is that, like, with a layer on top, with REV2, you can't solve it as a layer on top.
Okay, let's take that discussion offline into the doc and covering the other things. You all right?